Wilson, he is really great. Tim Wilson, he's gonna teach you today. Tim Wilson, you're gonna learn a lot from the quintessential analyst. Tim Wilson, you're gonna hear him today. Oh, Tim Wilson, do you know what he's going to say? It's gonna be about art, maybe data science too, I don't know. He will tell you. Everybody together, let's say, welcome to Tim Wilson. Can you jump? Thanks, Yehoshua. Always goes on just a little bit longer than anybody would be comfortable. So it's great to be back at Superweek, kind of like Matt, everybody who runs this and kind of makes it all come together. Kind of an amazing experience, and the people. So I'm thrilled to be here. So I realized that the talk that I'm giving, it is in many ways kind of the title and the description. It's been the same for all 3 years. I like to think that I brought new content every year. I was talking to Robert last night, and he said, well, don't do that thing where you walk through like what you've talked about every year for the past 3 years. And I'm like, ugh. So, back in 2017, he's like, yeah, you're going to talk about some journey. And I'm like, yeah, I talked about this journey I took to learn R starting in October 2015. By last year, the journey had continued. I'd gotten to where I could do some pretty amazing things with R. This is where I start replicating Doug's talk, because I actually have the picture of where I was levitating an MC using R. And last year was when kind of some light bulbs went on for me with things that Matt had been talking about with me for years. And it was actually at Superweek last year that the hashtag I've been Macker Soft hashtag was created. So kind of fitting that I think everyone in here with entropy and information theory, everybody got Macker Soft this morning. So planning ahead, expecting that to happen. I do have I've been Macker Soft stickers. So if anybody feels like they'd like to kind of wear that badge on their laptop that they have been Macker Soft, see me sometime today or tomorrow, you're welcome to a sticker. There's nothing wrong with being, kind of wearing that proudly. This is the laptop cover for a young lady I know quite well, and she's been Macker Soft. That's cool. It's actually my daughter. She's 13. What she actually got me for Christmas was a banner that said I've been Macker Soft. So that's not weird. That's not weird at all. So she has been Macker Soft. She I think has a similar degree of affection for him that I do. But Matt, one of the things that he finally kind of lit up for me last year was this idea of uncertainty. And even when we think about information theory and decision trees, we're working with these ideas of uncertainty, which I think is a huge challenge for analysts that we're going to have to constantly work on educating our stakeholders for the many, many years to come. And the big takeaway, it wasn't my idea. It wasn't Matt's idea. He'll tell me it was David Hume's idea, because we've got to go farther back, was that recognizing that marketers were always working with under conditions of uncertainty, which means we need to get comfortable with that there is no absolute truth out there, that there's a cost to reducing that uncertainty. We've got to do modeling, we've got to collect data, we've got to store the data, and no matter how much we invest, we're never going to eliminate uncertainty. So I was kind of excited that finally started to make sense for me. And then over the course of this last year, I heard Annie Duke on a podcast I listened to. How many people know who Annie Duke is? Anyone? So, Matt quotes Claude Shannon. I quote a retired professional gambler. But so that's what Annie Duke was, a very, very successful gambler, very, very analytical. She's written a number of books. And what she said on this podcast was, we have a problem. She actually said, we have a problem in America with thinking probabilistically, which I think is kind of profound. And her latest book really is about that, getting comfortable with the idea that we're making decisions under conditions of uncertainty, and that those decisions, in hindsight, seem like they were the wrong decisions. They weren't necessarily. We have a tendency to want to beat ourselves up to say, we picked the wrong option. But no, we picked the best option given the information that we had. We wanted to reduce uncertainty to the extent that we could and kind of go on about our day. But she says we're kind of too harsh on ourselves when it comes to looking back on, we didn't buy, if we beat ourselves up because we didn't pick the right lottery numbers every time, like that would be ridiculous, because we actually realize there's a very, very small chance there. But we make other decisions where it may be 60-40 or 70-30, and then it doesn't work out as we expected, and we're like, oh, I made the wrong decision. Not necessarily. So that's kind of my sort of bigger ideas. We're going to get super kind of tactical now. So I said this kind of applied data science, dabbling in data science. So what is data science? Ask 20 people what data science is. They'll give 20 different definitions, but they all will likely use a Venn diagram to describe what they think data science is. There's this post on KD Nuggets that has done a survey of all the Venn diagrams talking about data science. And because I've gotten more comfortable with sort of probabilistic thinking and uncertainty, I'm comfortable saying this is my 85% confidence diagram, Venn diagram, for what I think is a decent representation of data science. That it's computer science, so using Python or R, SQL, some combination of that to do stuff with data, putting that together with statistics and even information theory and these ideas and techniques, regression, decision trees, and combining that with subject matter expertise. It gets back to what is the business trying to do. And what I've realized is that I kind of thought we have to bring all of those together to get any value, which obviously we don't. We can get value just by combining two of these. But the idea is that we need to kind of go beyond just having subject matter expertise, just being experts in Excel. We do kind of need to expand our thinking. So that brings us to 2019. And 2019, my bold prediction, it is the year of applied data science. Okay, that's kind of silly. It's kind of like the year of mobile, kind of lasted for a decade and is still going on. But for me, it's kind of this constant journey, sorry, Robert, to continue to how can I apply, as I'm gaining these skills in these other areas, the ideas or aspects of data science to actually deliver value. So, think about our basic normal distribution. Here's what I'm hoping we get out of the next 30 minutes. I've got 4 examples, basically, maybe 4 1/4 examples. And the reality is all of those aren't going to be awesome and amazing to everyone in here. So my hope is that each one of you will see 2 or 3 of these examples and say, well, that's like mildly interesting or at least thought-provoking. I don't know what I'll do with it tomorrow or next week, but I'm kind of glad I saw it. I'm not going to go and demand that part of those 10 minutes of my life back. I'm okay with it. But then we've got kind of the out on the tail, the kind of lower probability areas. So my hope is that there's only one thing out here, but it's fine if you see one example and say that's the dumbest thing I've ever seen, or I've already done that, or that has no real world application for me, that's fine. And then my hope is that for many of you, there will be at least one example that you say, wow, that's pretty slick. I'd like to actually run back to my room and try that right now. Don't run back to your room and try it right now. One, if everybody got on the internet at one time, then it might not work. So that's kind of the idea. So I'm going to walk through 4 examples, and each one of them they're going to be structured the same way. There's going to be kind of an idea or a concept. We're going to dig into it a little bit. We'll dig into some a little bit farther than others. And then I've got what I'm going to call a treat for later. So how many people here actively use R right now? Okay. For you guys, if any of these are appealing, there is R code, there are notebooks, there's actually a published R pubs document, it's all in GitHub. There's one link at the very end of this that has all of this. And if you say that's kind of interesting, I'd like to take it and try it on my own data with the code, it's there, totally available. For others, we're using Shiny. There are 4 different URLs, links to web apps where you can just authenticate with Google and you can try what we're going to talk through with your own data. I am not a master of error checking and error handling, so let me know if you run into, hey, this didn't work for my data, I got this crazy error, I'll work on it. But it works basically on basic sites. Could not have done this without, again, I'm going to kind of repeat the sort of thing that Doug did in his session. Got to acknowledge Mark Edmondson. Where is Mark? He's here, right? There he is. So, absolutely. So the packages I used heavily rely on stuff Mark wrote, and then specifically to actually get the Shiny where anybody can log in and try it, getting authentication working, Mark was instrumental in helping me kind of work through some of the kinks on that. So just as Doug said, we kind of stand on the shoulders of others often in this industry. I imposed some constraints on myself intentionally because I wanted to have these as broadly usable as possible. So everything we're going to talk about works with free Google Analytics. There's no need for BigQuery. There's no need for Adobe Analytics in the data feed. That kind of means there may be not super sexy examples, but the idea is you'll get to thinking about, okay, what could I do if I was using my custom dimensions or custom metrics or was using enhanced e-commerce or really e-commerce functionality at all. So just with the base tag. So in theory, if you have a base level vanilla Google Analytics implementation, you can log in and try these out. I do want to be clear though, and this was kind of to my question to Matt earlier, like one of the things I was going to try was decision tree. On the dartistics.com site that Mark and I put together, we have classification, we have decision trees. It's not a particularly compelling example. So I'd love for somebody to say, hey, with free Google Analytics and a base tag, here would be kind of a somewhat meaningful classification example, because I'd love to write that. I kind of agree with Matt when he said, regression versus decision trees. I think those are two super, super powerful. They're both very, very powerful ideas if we get some intuition about them. I do not have a decision tree example. I almost had a k-means clustering example, but I figured I didn't want to copy Doug's entire presentation. But at the end of the day, the farther we get into this world, yes, the detailed data kind of trumps the data in BigQuery, or Adobe is now rolling out a freemium model, so you kind of have to go through a partner, but if you actually want to do some, if you're at FreeGA and thinking about moving maybe to Adobe, there is now a freemium model for that as well, and that starts to get you to the data feed. So that data is becoming more and more available, and that is generally where we want to head. So, there's my preamble. I think I'm out of time, so sorry, talk to me later, I'll give you the examples. Now, first example, pretty straightforward, pretty simple one. I haven't really figured out what to label it, time normalized page views or launch versus life cycle or content cohorts, I don't really know. Sort of settled on the tortoise and the hare. And this goes specifically to the world of content marketing. If you've got a blog where you're publishing once or twice a week, then this may be something worth digging into. What I've seen historically is when we've got content that's being pushed out is we shout from the rooftops, we put in our emails, we post it through our social media channels. And there's no statistics required. So this is one of those, the whole Venn diagram's not needed. This is just, this is coding and some subject matter expertise. So this is a particular, I know there's an analytics agency that you would hope that your content isn't going out like this, but there may be an analytics agency based out in Atlanta, Georgia, where when they tend to push a blog post out, they get their first big spike and then it drops way off. But it's pretty common to see that. You get the first excitement, people are kind of sharing it, it gets a little traction, and then it falls off and levels off with kind of ongoing traffic, and then it's giving you the benefits of SEO and content marketing type stuff. But what if I've got just these two blog posts and I look at them and say, which one actually did more for me? Which one was working better? Which one of these seemed to be generating more traffic? It's kind of hard to tell because they launched at different times, they had these big spikes, and they dropped back down to a sort of a flat level. So one thing I can do is, this is the time normalizing. Instead of plotting by day, let me plot from the point of launch. And so I'd asked some people who said, yeah, they've done this sort of thing before in Excel, but it's kind of manual to kind of shift around and figure out the first 30 or the first 60 days for each post. So this is being done programmatically. It's going and looking and saying, let me pull all the data for the last 18 months, and then for every page that I've filtered to, so maybe I'm only looking at things that are in /blog, what's the first day that has more than 5 or 10 or 20 page views? I'm going to assume that's the date that it's launched, call that day 0, and then line them up. I get to where I start to have a little bit more of an apples-to-apples comparison. It's still a little hard to tell because they spiked and then dropped way off. So the next little step was, instead of looking at just page views by day, why not look at cumulative page views by day? And now I can start to see that blue, the second blog post, after about 20 days, it had driven more traffic to the site. So this is using unique page views. It could use page views. It could use orders. It could use revenue. But it's a way to start saying, can I look at a bunch of these? Maybe I want to look at all my posts or all of my product pages and start seeing which ones outside of that initial bump, which ones are kind of staying on a trajectory where they're working particularly better or worse for me. So most of these I'm not going to jump over and log into the website, the web experience, but this is basically what you get if you try out that example. And you can filter, put in kind of a regular expression to subset what pages you want to look at. So that's kind of hopefully mildly interesting to some of you. The next is also a page level thing, and it's a little bit of a misnomer because it says page level correlation, which implies statistics. And yes, this one does actually calculate a correlation coefficient, but it's not really a statistics example. But the idea is if we take all of our pages, and this is where I think it would be, it's more useful if you're saying, I'm going to take all my product details pages, or all of my products. But it's a simple idea of saying, let's look at two metrics at once. And if one of them, the x-axis is typically some measure of volume, be that page views, entrances, unique page views, product views, and on the y-axis put another metric, we're probably going to see some sort of pattern emerge, and we can look for pages or products that sort of fall outside of that normal thing and say, what's going on with this, better or worse? Again, it's mildly interesting when it comes to using the base tag in GA. The web, this is really small and washed out. In this case, it's showing page views and exit rate on the y-axis. But doing it with entrances and bounce rate is another one to look at. And there are a couple of dots, if you kind of circle these, we've got some that have a high number of page views and a high exit rate. And that means that's the last page they viewed on the site. I've got some other ones that have a similar number of page views, but a low exit rate. And I can start looking at those, mousing over them, and saying, what's different about these pages? In this case, the ones that have the high exit rate are kind of standalone blog posts, so people are reading them, there's not really a call to action, and they leave. The ones in the bottom, in this case, are the About Us and Careers pages, so people are sort of continuing on. So to play around with that, just to sort of think about some subset of the content on our site, looking at it across two dimensions and saying which one of these kind of jump out is particularly good or bad. Let me mess around with different metrics and see what happens. So now we're going to move into where we're actually going to do some things that are maybe a little bit more kind of getting into the world of data mining or data science. And we'll start with some text. And I call this a throwback to 2017 because there was a gentleman here who competed in the Golden Punch Card. His name was Sebastian Brodeur. He's in Canada. And a big chunk of this is really kind of based on an idea of what he had done kind of an initial pass at. I also have layered in some stuff that a lady named Nancy Coons presented back at Adobe Summit in 2015. There's a simple little idea. And then more recently, there's a R package called Tidy Text that Julia Silge co-wrote, and she's co-written a book and put together a site, a lot of good information. And that kind of let me push this a little bit farther to get to some things that are more than just kind of simple cleaning up of the data. So the idea is that the site search on our site is the voice of the customer. That is a customer typing in their own words what they're trying to do. So as smart speakers emerge, as search engines get more and more sophisticated, the consumers tend to expect, whether our search functionality is really all that fancy or not, they start to think, I can type in exactly what I'm looking for. I can put more detailed searches in. Even if the search engine doesn't return great results, they've still told us what they're looking for. So what Nancy Coons had said several years ago was, well, one thing we can do with that is people will type in entire questions. And you could do this just in Google Analytics. Just do a simple little regex search for all search phrases that start with a question. How, what, why, when, where, who, and get that list. It's out on the long tail, but you get this nice list of questions of what people have actually asked, and you could even filter it further, but you get this set of questions and can start to say, wow, these are people saying this is what they're looking for. We don't really know how many people are looking for it, but generally it kind of gives us a good jumping off point to say, aha, this is something people are expecting to be able to do on the site, and they're going to the search box to do it. So how to cash a check by taking a picture. How can I find my account? How do I change the username on my account? So that's kind of this standalone little bit. The next part is actually doing some light text mining. And I've People either love or hate word clouds. I think a lot of people hate word clouds because people just take raw data, throw it into Wordle, and then they say this isn't that useful. But I actually believe that word clouds can be kind of useful if we do a little bit of cleanup of the data, of the words before we throw it in. So what we're going to do is we're going to focus on just individual words in the searches, even if somebody's searching for phrases. And we get into the world of n-grams, like n-gram pairs of words or triplets of words. But in this case, we're going to say, let's just look at individual words and see what happens when we do a little bit of cleanup. So we're going to do like 3 or 4 things to our raw data. So this is just a search phrase and unique searches data. We're going to pull it in. The first thing we're going to do is unnest the terms. So if I've got a 2-word phrase, routing number, I'm going to turn that into 2 rows in my data. One for routing and one for number. I'm going to use the same number. I had 42 unique searches. I'm going to say, well, that's 42 searches for routing, 42 searches for number. If somebody searched for just a single word, I'm just going to keep it as is. So that's the unnesting. The next thing we're going to do is make all the terms lowercase. Now, hopefully, in your Google Analytics implementation, you've got a filter that does that anyway. But if you don't, it's easy enough to say, let's take each of these words, make them all lowercase. You can even do that in Excel pretty easily. The next thing we're going to do is word stemming. And word stemming is finding the root of the word. And it's not necessarily a word in and of itself. But if I take the words routing or routing, route or route or routes, and I run it through a stemming algorithm, it's going to say the stem of that is R-O-U-T. And a lot of times the stem of a word is not a word in and of itself, which can be confusing to stakeholders if we say, hey, you're a bank, and the most popular search term on your site is route. They'll be like, that's weird, there's no way, that doesn't even really mean anything. So there's one extra little step that I do here, which is of all the words that got collapsed into a single root, let me find the most popular one, the one that had the most searches for, and kind of translate it back to that. So I started with routing, route, and routes, and I kind of transformed them all just to the word routing. So it's a little transformation, but it starts to be like, really, those are all kind of saying the same thing. They're the same idea, so that's okay, and it kind of lets me kind of dedupe this stuff. The next thing is removing stop words. We don't care about articles and prepositions and pronouns. So each language, it's easy to get a list of stop words. Say, let's take all of those out, because that's just kind of noise and clutter and not really relevant for this. So if I go through all of that, and again, using R, Python to do this, I mean, each one of these slides is basically one line of code. What I go from is, on the left was my original search report. Rates, 68 unique searches, 1,000 ton CU, 44, routing number, 42. On the right is kind of the tidied up data, where I've gone through all those transformations and then kind of collapsed, aggregated back. So that tidied up data is officially a term frequency matrix. It's each term, what was the frequency with which it appeared. And a little hard to see, but the word rates, and actually even going another 10 terms deep, rates was capitalized, rate, the single word, showed up, but all of those really wind up getting collapsed into a single top term. So I'll wind up with a total that is a much higher. It says really the word or some derivative of the word rates appear 250 times, which is hard to see if I'm just looking at the raw data. So now I can take that term frequency matrix and spit out a word cloud, and I start to have a word cloud that actually doesn't have a bunch of junk and clutter in it. I could just look at the term frequency matrix. The one other thing, it's not shown in this example, but it is available in the web application, is sometimes there are words that are super, super dominant. If I am a shoe retailer, then people may have searched for red shoes, blue shoes, purple shoes, casual shoes, and when I go through this whole exercise, the most dominant huge word in the middle is shoe. And that's not that useful. I'm a shoe retailer. So I may want to say, let me take some of those words out that I know that they're super, super dominant. So let me kind of selectively remove them and have that word cloud generate, which is another, I think it tends to make it a little bit more useful. So that's just kind of basic text mining. The thing that Julia Silge had written that I got to now play around with, and I'm kind of excited about, is topic modeling. And topic modeling is essentially unsupervised exercise. where it's kind of like cluster analysis, but for words. And just taking that term frequency matrix and specifying how many clusters do I want to use for that, it goes through and figures out topics, and it assigns for each word a probability that that word is part of that topic. And then we can go through and say, well, which are the words, for each word, what does it have the highest probability topic to be in? So this is an example of those, it's only three, I picked three groupings, three clusters of that same search data from the same bank, and starts to break out, okay, there's kind of rates and loan rates, there's kind of checking and routing and checking account stuff, and there's holiday and deposits, some other stuff there. And you can play around with how many of these clusters do you want. It doesn't always bear fruit. I've got a client that it was actually much more interesting. The problem is when it's much more interesting, it winds up being much more obvious who the client is. So, but if you've got a decent volume of search, it's worth kind of playing around with this and saying, can I start to think about the major sort of topics or ideas that people are looking for that can start to guide how we might want to think about our site and our content taxonomy. So this is with site search. The 0.25 example here was that I've also tried this with Twitter. So taking all of a user's, you can do it with tweets, but I'm kind of intrigued with taking all of an account's followers and their descriptions, and then do this exact same exercise. So this is the Digital Analytics Power Hour Twitter account. So at Analytics Hour, all the followers of that, and doing this exact same exercise, and just swapping out, saying instead of using site search data, use the descriptions of all of the users. And we can start to group them. There are people who are kind of analytics, bubbles up a lot in their descriptions of themselves. There are people who it's digital and marketing, bubbles up a lot. And then there's kind of this web, passionate travel, kind of this kind of other miscellaneous bucket. The Twitter one, there's not a web-based example just because of the limits on Twitter's API. It would kind of croak the first time somebody decided Gary Vaynerchuk they wanted to try this on his. So I'm really kind of intrigued by what we can do with kind of simple available text to us to kind of think about it and look at it in different ways. So now we're going to get to my favorite example, which is just regression. And it's specifically regression with nominal variables or categorical variables. So it's going to be kind of a dumb example. You know, when Matt says, oh, I'm only using 12 data points, well, we're just going to use day of week and sessions. But I spent a good 1.5 to 2 years being confused when I was looking at Google Analytics data and saying, how do I actually do a regression on channel grouping? Or how do I do a regression on device category? So I guarantee there are some of you who are going to think this is the most slow and ponderous thing I'm about to walk through, but I'm going to hope or assume there are at least a handful of you who are going to be like, thank you, I've never quite understood how I would do that, and that's actually kind of cool and kind of slick. There's no log2 formulas, there's no entropy, but they're dummy variables. So I think that's appropriate that I'm following on as a little bit of a simpler version of following on behind Matt. So what we're going to do is we basically want to just predict sessions based on what day of the week it is. We know that tomorrow is Wednesday. So that's something we absolutely know. What can we say about what our traffic to our site will be tomorrow just by knowing that tomorrow is Wednesday? So ultimately we want to get to where we've got our actual data. We'd like to sort of put a prediction just using one variable on top of that. So the broader application of this, I am using just sessions and just day of week. But if you think about device category or channel grouping or source, any of those other kind of categorical variables, this applies to that. It's not that interesting with sessions because it turns out that the number of desktop sessions is predictive of how many sessions we get from desktop. So it gets kind of boring when we're looking just at sessions. But if we were using orders or revenue or some other metric, other categorical variables would work. So hopefully that makes some sense. So we're going to take the day of the week. So here's our standard, and I guess one other caveat, when working with time and time series, we probably want to use some sort of forecasting algorithm instead, like a Holt-Winters forecasting and time series decomposition. So this is a little bit different, but it's kind of interesting that it winds up at the same point as using a forecasting technique, if we just say, let's do regression with day of week. So here's our data. This is the last 90 days of data. We see what we see a lot of times in web analytics data, the dips on the weekends, the peaks in the middle of the week. And it's kind of noisy. It's got some weeks that are higher, some weeks that kind of drop down. So, and what we want to do is generate from that a formula that says, given the day of the week, and only the day of the week, let me predict how many sessions will actually come to the site. So this is 52 plus 203 times Monday plus 193 times Tuesday. So we start looking at that and say, okay, so you're telling me my formula is 193 times Tuesday. So 193 times Tuesday, this is where my brain would always start to lock up. I'm like, why don't you tell me that I should do 47 plus tacos? I don't quite see how we multiply by a day of week. And that kind of threw me. So the way we get to that is we have our simple data. So this is a simple Google Analytics query, nothing too fancy about it. And if we look at our formula for a line, which is if you look at, instead of, we say B instead of beta, but keep things simple. So what's our Y? Well, that's easy. That's our dependent variable. That's the number of sessions. That's what we're trying to predict. Where things to me got a little weird was, what's my independent variable? Well, I said I want to use day of the week, so that should be X, but that gets me to this 193 times Tuesday, which doesn't make any sense. So how do we get to that? Well, we start with our basic plot, simple time series, but we're like, we don't really care about the date, we care about the day of week. So how would we plot this with day of week instead of this time series? Well, we could do a box plot, where we've got 12 or 13 observations for each day of the week, and each one of those had a number of sessions, and so I've got the median for each day, I've got the first, second, third, and fourth quartiles, I've got outliers, but I'm representing the same data, but I'm focusing on this categorical variable rather than the actual date. This isn't a strictly required step, but to me it's kind of helpful to get some intuition around how we're thinking about the data differently to do this. So what we need to do is create dummy variables. And dummy variables are like brilliant, and even that I sort of understood what they were, but I didn't fully understand how they worked. So if we've got our original data, the way we make our dummy variables is we take that weekday and we turn it into a bunch of columns. So we make a column for each day of the week. So, and then we code it with a 0 or a 1 as to say, was it this weekday or not? So if we look at this Monday, October 22nd, I've got a 0 for Sunday. It's a Monday, so it's a 1. It's a 0 for each of the other days. Pretty straightforward. But maybe you're looking at it and saying, you got a little sloppy there, Tim. I only see 6 columns. What happened to Saturday? Why is there no Saturday? And that's another kind of important little thing to recognize is that no, Saturday's there. It's kind of invisible. I actually don't want Saturday. I always want to have k-1 dummy variables. The reason Saturday's there is if we look at a Saturday, if it's not Monday, not Tuesday, not Wednesday, not Thursday, not Friday, then it must be Saturday. So it's actually already represented there. So when we make dummy variables, we always have k-1 columns based on the number of levels or the number of values that we have. So this is not going to get super, super complicated, so I don't have to warn you like Matt did that we were about to make our brains really, really hurt. Once we have the data transformed that way, then it's really just a couple of lines of code in R. This is the only code we're going to look at. But we're going to do 2 things. We're going to run a full regression, say take my 6 variables and use that to predict sessions. And that's just one little line of code. Take sessions as my dependent variable, the little tilde and a dot says take every other variable and put it against it, and my data set is analysis data. There may be some variables, some days of the week that really aren't that predictive. And I don't necessarily want to include them, so I'm going to do one other step, which is a stepwise regression that says, go and evaluate, kind of add and remove variables, and find the model that seems like the best fit with the least number of variables possible. There are some other things. There's still some risks of overfitting. There's a whole topic of k-fold cross-validation and other things to be worried about that we're not going to dive into, but stepwise regression is nice because it'll just remove kind of the not particularly helpful values. So with just those 2 lines of code, R and really Python, any tool sort of spits out a super intuitive table. It's actually better that this is small and washed out and you can't read it, because that's about what it looks like when you can read it up close. So you kind of have this sort of reaction of, okay, what do I do with that? And it turns out, while all of this matters, all of these are important numbers, there's just a subset of them that we actually really kind of look at first. One of them is the p-value, and the p-value written, in this case, 4.354E-11. I don't know why. I'm slow to sort of figure out, okay, what is that really saying? Well, that's 4.354 times 10 to the minus 11, which is a really, really small number, which means our p-value is way less than 0.01, which means we can generally say it'll cause purists to have a little bit of a heart attack, that this is overstating, and the internet is awash with people debating p-values and not reading too much into them. But I'm going to say we're generally pretty good. Hey, this is saying that the model actually seems useful. It's statistically significant at like a 99% confidence level. So that's check mark number one. The next thing we'd look at is this adjusted R-squared, which is what it says it is. It's our R-squared, but there are just some reasons that it gets tweaked a little bit. So we look at the adjusted R-squared. In this case, it's like 0.4584, or we could say write it in purple text with a superscript. And I was kind of conditioned to say, I want an R-squared like 0.8 or 0.9. Like, how useful is a 0.45 R-squared? Well, it's actually kind of nice. I've only picked this one stupid simple variable of day of week, and it's saying that 46% of the variation from day to day in traffic to my site is explained by this one simple model. So you start to say, oh, wow, so if I add some other factors to the model, how much higher do I get it? But I'm explaining almost half of the traffic to my site essentially just by knowing what day of the week it is. And then the final thing is the table, the coefficients table. And we can clean that up. Really, what's the value? What day of the week is it? The actual coefficient, that's the multiplier. And then the PR, parentheses, greater than absolute value of t, that's the p-value. So we can sort of translate the p-value into a confidence level for each variable in our model, all of which in this case, and we'll see in this case, Sunday's actually gotten dropped. We didn't use Saturday, and Sunday actually went away as part of that stepwise regression. So we've got really only 5 of the days of the week that we're using. And so with that table is basically telling us what our formula is. The 52, our intercept, that's just a constant. It's our baseline. It's where we start. And then we've got each of the others. This is 193 times Tuesday, shows up in the formula below. We just kind of string that out. So now we go back to our dummy variables to actually say, can we actually get some intuition about how this works? So this is the same table of data, except I've added the predicted outcome. And it really is just plugging in the numbers that if I pick a date, I've got a bunch of zeros. So when it comes to that, how do I multiply 193 times Tuesday? Well, if I've got this date, which is a Wednesday, then I take 52, my intercept or my baseline number. It's 0 is for Monday, so that's 0 times 203 plus 0 times 193. Really, I just get the Wednesday and say 1. So I take the coefficient value. So 52 plus 177 is 229. That's my predicted value. If I'm looking at a Saturday, I think this is, that was my reference variable, that was my drop dummy variable, so my prediction is just the intercept, it's just 52. This also dropped Sunday, the regression said Sunday's really not that useful or predictive, so it's also really just 52. So it really is just plugging numbers into a formula, and that's where the prediction's coming up. Now there's a whole thing like plotting the residuals and these other things that we're supposed to do to be really kind of purist about this. We're not going to do that, but we are going to say, well, let me actually look at how my predictions matched up with my actuals. And so the red line is my intercept, the dashed line, because I'm like, that's good to know where it is. And then the gray dotted line is what I predicted, and we can see the actual values to see sort of how well did that fit. So this one I'm going to hop over, because the question would come up, well, why did I drop Saturday, and why not drop Tuesday or Wednesday? And it doesn't really matter. This is the only web example I'm going to show, and we will cross our fingers on the internet so I don't have to go to the video. So if you go to this, you get prompted to say, give access to your GA data, and then you'll be able to pick what you want to use. You can change the date ranges. If it's a large site, you can turn off anti-sampling. But the example I just walked through in slides, this shiny app really is kind of more meant to be giving you intuition. It just walks through. This is our base data. It's then got a box plot. So this could be done with your data. We calculate these dummy variables. And what we'll start to see is we have an option to change what we're using for our dummy variable. And it really doesn't matter. There are strategies for picking one, but the model doesn't really change. The results don't really change based on what you do. We spit out our kind of ugly format. We've got a simpler, so in this case, this is saying p-value for the whole model of less than, very small. And here our R-square is 41.5. And then we get the actual visualization. And if you want to plug in the data, it'll spit the data back out, and you can do that same exercise. But to me, that idea of which dummy variable, it defaults to Saturday. But it's kind of useful to start thinking about how does my formula change when I change the dummy variable. It actually is going to change my intercept. It's going to change all of the coefficients. But the results, my R-squared is going to change just a little bit, but not in really a particularly meaningful way. So hopefully that's kind of useful to play around with, and you can start thinking, what if I was using revenue? What if I was using other variables rather than day of week? If I plug those in, if I started combining multiple variables, if I started looking at interaction effects, I want to see how mobile from social, how does that interact with each other? Is that something that stays when I run the stepwise regression, or is that not particularly predictive of revenue in any way? And then I can also look at the coefficients and say which ones seem to have the bigger impact, kind of relative impact of each of those channels. It doesn't matter which dummy variable I pick, I can still sort of compare the coefficients and get a sense of kind of what the bigger contributors or the bigger drivers are. So back to kind of our, where did we start with how do we actually do this work with the categorical variables? Hopefully this kind of gets us to, that's kind of cool, that's exciting. I'm using aggregated data, and I'm able to do this sort of work with it and start to think about how can I actually start to be kind of predictive and understand the drivers of an outcome on my site just through simple linear regression. So, now what? This is the spot where at the beginning of the session, I always go to somebody and I say, hey, I'm going to get to this slide, and I'd like you to take a picture. And then I get there, and I realize he needed to explicitly be reminded to take the picture. This is a guy that I drink with on Thursday nights, and we're just trying to make this picture as widely spread as possible. You squint, it kind of makes sense here. So what we've gone through is all of this that we've looked at is at one bit.ly link. So it's a GitHub repository. It's got the R. It's got links to each of the web applications. It's got the code. It's got a little bit more of a description. It will have this presentation on it as well. And then I tend to forget to actually plug the Digital Analytics Power Hour podcast. If you're a fan or a listener, I also have stickers for that. So, and if you'd like a sticker, please see that. And with that, I have no idea if I ran way over or if I'm... Round of applause for two.